Welcome to lesson 6.4. Today we're going to talk about vectors, and specifically we're going to talk about dot products. So what is a dot product? A dot product of two vectors is finding the scalar product of these two vectors. So if you remember, scalar, when we had that, we saw that in our vector properties where we had a scalar k times a vector u. This is just a number. So the dot product is going to result in a number, not a vector. So how do we find the dot product? The dot product of two vectors, u and v, can be found by using the following formula. U dot v equals u1 v1 plus u2 v2. Okay, so let's actually just write an example of this. Let's say we have vector u equals 1, 2. And vector v has the components -2, 3. The dot product of vector u and vector v would then equal 1 times a -2, that's our u1 times v1, plus 2 times 3, which is our u2 times v2. So this would equal -2 plus 6, which would equal 4. So our dot product of u and v equals 4. So like I said, this is a number. It's always going to be a number, not a vector. We're not multiplying the two vectors together. We're finding the scalar product or the dot product of these two vectors. Okay, so now let's go on to some properties of dot products. Just like we had properties specifically of vectors, now we're going to have properties of dot products. So some of these are very similar to what you've already seen. U dot v is going to equal v dot u, kind of like our addition property of vectors. So u dot v, or the dot product of u and v, is going to equal the dot product of v and u. The dot product of our 0 vector and v is going to result in 0. And this is just a number. Remember, this is not the 0 vector. This is just the number 0. The dot product of u with the sum of vectors v and w is going to result in the dot product of u and v plus the dot product of u and w. Now this one's a little bit different. The dot product of a vector with itself, so here we've got v dot v, equals the magnitude squared. So remember, this is our symbol for magnitude. And what this is saying is that v dot v is going to equal the magnitude. And if you remember, you find the magnitude by taking the square root of the sum of their squares. So v1 squared plus v2 squared. And it will result in this being squared. So when we do that, we end up with the dot product of v with itself would be v1 squared plus v2 squared. Lastly, the scalar product with the dot product is going to result in, remember this is a scalar factor right here, results in the scalar number times the dot product, and it doesn't matter what order. So we can have c times the dot product of uv, or we can have u times, or u with the dot product of cv. So either one of these are all equivalent to each other. Okay, so let's go ahead and erase this and go on to an example. So we need to find the following. We have the dot product of u and v, and we're going to multiply that to vector w. So remember, this is going to result in a number, and that number is going to be multiplied to this vector. So our actual answer is going to be a vector. So first, let's find the dot product of u and v. So u dot v equals -1 times 2 plus 3 times -4. So we end up with -2 minus 12, which is -14. So that's our u dot v. So now we're just going to take this number and multiply it to our vector w. So we have negative 14w, which is going to equal negative 14, because we have negative 14 times 1, comma, 28. Or if we were to write this in a linear combination, we would have negative 14i plus 28j. These are the same vector right here, just written in the component form versus the linear combination. Okay, so moving on, now we are going to find the angle between two vectors. So we learned earlier how to find directional angles. Now we're going to learn how to find the angle between any two vectors. And they can be found using this formula. So cosine theta equals u dot v, so the dot product of u and v, divided by the product of their magnitudes. Let's actually use this and put this into an example. So we need to find the angle between our vector u and our vector v. These are written in linear combinations. So we first need to find all three of these pieces of information. We need its dot product, we need the magnitude of u, and we need the magnitude of v. So first let's find the dot product between u and v. So that's going to equal 6 times a negative 4 plus 3 times 4. So it's our u1 times our v1 plus our u2 times our v2. So this ends up with a negative 24 plus 12. So our answer is negative 12. Okay, so now let's find the magnitude of u. So that equals the square root of the sum of the components, of the squares of the components. So we have 6 squared plus 3 squared, which equals the square root of 36 plus 9, which equals the square root of 45. That's our magnitude of u. Our magnitude of v equals the square root of negative 4 squared plus 4 squared, which equals the square root of 16 plus 16, which equals the square root of 32. Okay, so now that we have everything that we need to plug into our formula, let's go ahead and plug it all in. So we're going to go up here and plug in everything that we've got. So our dot product of u and v is negative 12. That's divided by the product of the magnitude. So the magnitude of u is square root of 45 times the product or the magnitude of v, which is 32. So remember, this is cosine theta that we're solving for, first and foremost. Then we're going to use the arc cosine or cosine inverse to find the actual angle. So when you put that into your calculator, you have negative 12 divided by the square root of 45 times the square root of 32. You end up with negative 0.3162. So now we need to find theta. So in order to find theta, we're going to take the inverse of our answer. So cosine inverse of negative 0.3162 will give us our theta or our angle, and the angle between these two vectors is approximately 108 degrees. So this is how you would find the angle between two vectors. And what that's saying is, for example, let's say we have a vector going right here, and we have another vector going this direction. What we're finding is this angle right here, the angle between these two vectors. So that's what this formula just allowed us to solve. Okay, so let's move on. Now we're going to learn a new term, orthogonal vectors. And what orthogonal vectors are is that means that they are perpendicular to each other. So there's a very unique property about perpendicular vectors in that their dot product equals 0. So if you have two vectors that are orthogonal to each other, then their dot product is going to equal 0. So let's figure out if the following two vectors are orthogonal. So we need to find the dot product between u and v. All right, you should be getting used to this by now. So dot product, we're going to take 2 times 6 plus -3 times 4, which equals 12 minus 12, which equals 0. So yes, if we were to graph these two vectors out, we would find that they would be perpendicular to each other because the resultant answer was a 0. Okay, so that is it for today. Hope you guys learned something new and look forward to seeing you in class. Take care. Bye-bye.